Okay, so welcome back, and in this example we're going to deal with another discontinuity, but this time it's going to be at 0. Because here we get x is equal to 0 here, and this goes to negative infinity. Okay, so there's a discontinuity at 0. Okay, so we're going to rewrite this and see what we can do. Okay. Now notice also there's this is also a indeterminate form. So we could use L'Hopital's rule, but let's see what happens here. Because it is continuous everywhere else, it's just at 0. So let's use limits and see what happens. Oh, by the way, we can also integrate this by using integration by parts. So let's do that, see where that leads us. So we're going to rewrite this as a limit. So the limit as t approaches 0 from the right of the integral from t to 2 of x ln x dx. Okay, and so now integration by parts. So we're going to make, in this case here, we're going to make u, because this is, we can't integrate this. So this is going to be our u. So u is going to be the natural log of x. dv is going to equal x dx. So that means du equals 1 over x dx. And v is going to equal 1/2 x squared. Okay. Okay, so now let's plug this in to our integration by parts formula. So this is going to be the limit. As t approaches 0 from the right, and now we're going to do uv, which is going to be 1/2 x squared natural log of x evaluated from t to 2 minus the integral from t to 2 of v to u Okay. So now let's simplify this and integrate it. So you get the limit as t approaches 0 from the right, 1/2 x squared natural log of x minus this is just going to be x dx. And so now we get the limit as t approaches 0 from the right. And we get 1/2 x squared natural log of x minus 1/4 x squared evaluated from t to 2. So now what does this give us? This gives us the limit as t approaches 0 from the right. Excuse me. Okay, so we get 1/2 times 2 squared times the natural log of 2 minus 1/4 times 2 squared minus everything evaluated at t, so that's going to be 1/2 t squared, natural log of t minus 1/4 t squared. So, now, let's continue simplifying this. And what do we get? So up here we get, so this is just a number, this is just a number, and so these got t's, and see what happens there. So this is just going to give us what? It's going to give us 2 natural log of 2 minus 1. And this is going to give us minus so here we get 0 times negative infinity again. And so this goes to 0. So we get the limit as t approaches 0 from the right of 1/2 t squared natural log of t. Now this here is an indeterminate form. So now we're going to have to use L'Hopital's rule. Okay? Because again, with limits and with indeterminate forms, again, to see that this is an indeterminate form, write this as ln of t over, we'll pull the 1/2 out. This is going to be 1 over t squared. And so this gives us the indeterminate form of infinity over infinity. So let's see what happens if we take the limit. Okay, so far we've got this. So we just need to figure out what happens to this limit. So let's take the limit, and we're going to rewrite this and then take the derivative using L'Hopital's rule of the top and the bottom. The derivative of the top and the bottom. So if we write the limit as t approaches 0 from the right, and we've got natural log of t divided by 1 over t squared. Again, I just rewrote this as a fraction. Now I can use L'Hopital's rule to say that this is the same as the limit as t approaches 0 from the right of the derivative of the top and the bottom. So the derivative of the top is 1 over x. The derivative of the, oops, not xt. The derivative of the bottom is going to be negative 2, right? So negative 2 divided by t to the third. Okay? And so now, what happens is this is the limit as t approaches 0 from the right. And well, what happens to this? Well, if you simplify this, this just becomes that, which just becomes the limit as t approaches 0 from the right of t squared over -2, which equals 0. Okay, so we just showed, using L'Hopital's rule, that this goes to 0. Okay? So we end up with our answer being 2 natural log of 2 minus 1. Okay, so this converges. And it converges to this value. And that's it. Have a great day.